Hello everyone, and welcome to Science and Engineering World, where I present mathematics, more mathematics, much more mathematics. In this presentation, I would like to present to us the relationships within the properties of a right-angled triangle. My name is Olutola Fakehinde. ABC is a right-angled triangle, which is sometimes called orthogonal triangle, and right angle because the line AB and AC, they meet perpendicularly, and this angle is 90 degrees. The side facing A, which is BC, I denote with small letter A. The side facing B, which is AC, I denote with small letter B. And the side facing C, which is AB, I denote with small letter C. It is an established fact that all the angles of a triangle are 180 degrees. That is, angle A, we use that symbol for angle A plus angle B plus angle C equals 180 degrees. So this is an established fact. Alright. But we know that angle A is 90 degrees. So angle B plus angle C must be equal to 90 degrees. Let's look at the relationship between the sides of this right angle triangle by using Pythagoras theorem. That's small a, that's BC, which is facing the 90 degrees, is an hypotenuse. Pythagoras says that the square on hypotenuse, that is that square, which the area of it is a squared, so the area of that is a squared, must be equal to the area of the square on the other two sides. So this is c squared, and then the area on the other side, which is b squared. We can now see that a squared, which is the square on the hypotenuse, will be equal to b squared plus c squared. Okay. This is the established relationship between the sides of a right-angled triangle. Now, we are looking at an angle here which we name theta, that's angle C. Looking at angle C, we see that this AB is facing C, so we call it opposite to C, to C. And then you can see here that theta is touching A, but A is hypotenuse because it is opposite to 90 degrees, and it is touching AC, which is B, on this side. So it is near to AB, it is near to AC, which means that it is adjacent to it. We want to establish the relationship between the angles and the sides. So we use the acronym SOHCAHTOA. SOHCAHTOA here means the first three. This first three is saying sine, that's the S there, sine theta is equal to, like we have seen, opposite over hypotenuse, that is opposite over hypotenuse. And that gives us opposite is C over hypotenuse is A. Cos theta is adjacent over hypotenuse, which is adjacent here is B over hypotenuse is A. Again, tan, which is 12, tan theta is opposite over adjacent, opposite over adjacent, which gives us opposite here is C and adjacent is B. Good. So this is the relationship between the side and the angle. Now I want to establish the relationship between sine, cosine, and tan. We have a table here. This table has 4 columns: angle, sine, cosine, and tan. And it has some values inside. These values are obtained from a video that I've done before. I'm going to put the link below so that you can see how we generate these values. Okay, now let's observe. We see here sine 30, which is half, is we also have cos 60, which is half. So in that case, we can say that sine here, sine 30 equals to cos 60. So let's put that down. That is sine 30 degrees equals to cos 60 degrees. Equally, if you look at sine 60 and cos 30, we see similarity there again. So we can now say that sine 60 equals to cos 30. If you go down to 0 and 90 degrees, we see that sine 0 is also equal to cos 90. And sine 90 is also equal to cos 90. So we have here that relationship. Again, if you look at 45, we see that this is also equal to that. So sine 45 equals to cos 45. Alright. And that means we can establish a relationship that we cut across, whether it's 45, 60, or 90, or 20. So we call the angle to be theta. Let's say if theta equals to 30 degrees. Good. So we can now say that sine theta will be equal to cos. Now we have 60 degrees here. How did we get to 60 degrees? We will see that if we subtract 30 from 90, we're going to get 60 degrees. So 30 is now theta. So we're going to say it's equal to 90 degrees minus theta. So this gives us the relationship between sine and cosine. We can say also in the reverse that cos theta equals to sine 90 minus theta. And this also is well funded. So we now have a relationship between sine and cosine. So we want to see how theta relates to these two. Let's take a look at 45. So if I divide sine 45 by cos 45, then that will give me sine 45 degrees over cos 45 degrees will be equal to half 1 over root of 2 divided by 1 over root of 2. So if I change this denomination sign or the division sign to multiplication, then I can have 1 over root of 2. Now, once I'm changing that division sign to multiplication, then the denominator will be inverted. So we're going to have root of 2 over 1. That is, root 2 will take root 2, so we have 1 over 1. And that is the same thing as tan 45. So in this case, we can then say that tan 45 equals to sine 45 divided by cos 45. So I will say that if 45 degrees equals to theta, or if theta equals to 45 degrees, then tan theta equal to sine theta over cos theta. So this is a just tested by saying if theta equals to 60 degrees, then tan 60 will be equal to sine 60 over cos 60. Which will give us sine 60 is root 3 over 2, root of 3 over 2, and cos 60 is 1 over 2, that's half. Which, if I now change the division sign to multiplication sign, I now have root of 3 over 1, root of 3 over 2, multiplied by 2 over 1. Because we invert the denominator, and that 2 will take 2 And so we have root of 3 over 1, which is, we can now see this value is the same as our 60 degrees. In summary, we have demonstrated the relationships between the lines and the angles of a right angle triangle by using these expressions, and at the same time we went to look at relationships between angles and lines with these expressions, etc. And then we also went to look at the relationships between the angles themselves, where we have sine and cosine, and then tan and the ratio of sine and cosine. Find this video very useful. You may give a thumb up, share with others, comment, because there are so many ways to solve mathematics, and then subscribe the notification button so that when I post numerous video clips like this, you'll be able to see them firsthand, and usually keep having fun because mathematics is fun. Lastly, keep studying.